Assalamu alaikum warahmatullahi wabarakatuh. Last class I was explained you about the structure of xenon compounds. Xenon forms the compounds with the higher electronegative elements like fluorine and oxygen and gives the compounds. Xenon if combines with the fluorine, those compounds are called as xenon fluoride. Xenon forms three types of fluorides. First one is the XeF2, that is the xenon difluoride, and second one is the XeF4, that is called as xenon tetrafluoride, and third one is the XeF6, it is called as xenon hexafluoride, XeF6. Yesterday we completed up to the structures of these xenon compounds that is those are xenon compounds. I was explained what is the structure of the XeF2. Before going to that, Xe plus F2 okay gives rise to XeF2. This is the preparation. Xe plus 2F2 2F2 gives rise to XeF4. This is the preparation of XeF4. Xe plus 3F2 gives rise to XeF6. Okay. In last class I was explained about the preparation and also structure of the XeF2, F4 and F6. Just once again I am repeating that. XeF2, what is the structure of this XeF2? For that you have to draw how many lines? Preset your paper, you have to write 6 lines. 1, 2, 3, 4, 5, 6, 7, 8 lines you have to draw, because it is belongs to 8th group. So in this 2 fluorine atoms we are adding. Remaining 3 are lone pairs, 1 lone pair, 2 lone and 3 lone pairs are there. It is LP, it is also LP, it is also LP. That means on the xenon 1, 2, 3, 4, 5 electron pairs are there. That means it undergoes which hybridization? sp3d hybridization. In XeF2, Xe undergoes sp3d hybridization. In sp3d hybridization, as a result 5 hybrid orbitals are formed. Among them 2 are which pairs? Bond pairs XeF, and 3 are lone pairs. Like the shape of the molecule is the linear shape. This is about the XeF2. Now XeF4 how it is prepared? Xe 1, 2, 3, 4, 5, 6, 7, 8, because it is the 8th group element. 1, 2, 3, 4, 4 fluorine atoms I have written it here. Now then these two become one lone pair and these two become one lone pair. So this is the one lone pair and this is the one lone pair. So see that how many electron pairs are there on the xenon? 1, 2, 3, 4, 5, 6. 6 electron pairs are there. That means on the central element 6 electron pairs are there. That means it undergoes, you have to consider like this, sp3d2 hybridization. In that sp3d2 hybridization, as a result of that, how many hybrid orbitals are formed? 2, 3, 5 plus 1, 6 hybrid orbitals are there. Among them 2 lone pairs are present. These are the 2 lone pairs, and 4 fluorine atoms are arranged in this manner. That is the structure called as the square planar structure. This is about the XeF2 structure. Now next about the XeF6. XeF6, once again Xe 1, 2, 3, 4, 5, 6, 7, 8. This is belongs to 8th group, therefore I have written 8 lines like this. So what we have to prepare? XeF6, 6 fluorine atoms like this, 1, 2, 3, 4, 5. Okay, XeF6, 1, 2, 3, 4, 5 and 6, 6 are over. See that this is the bond pair, that is 1 electron, 2 electron pair, 3 electron pairs, 4 electron, 5, 6 electron pairs, and 1 lone pair is present. 1 lone pair is present. That means how many electron pairs are there? 1, 2, 3, 4, 5, 6, 7. On the xenon 7 electron pairs are there. Among them 1 lone pair and remaining are the bond pairs. That means it undergoes, in this XeF6, xenon undergoes sp3d3 hybridization. Now then how you have to draw the structure of the xenon hexafluoride? Once again you have to arrange the 4 fluorine atoms like this. Okay, now next another one. This is another one. This is the sixth fluorine atom. Okay, so this is our, and one lone pair is there. Shape of the molecule is the distorted pentagonal bipyramidal, or shape of this molecule is octahedral shape. Octahedral लिख लेना. These are the shapes of the xenon fluorides, xenon difluoride, xenon tetrafluoride, xenon hexafluoride. Then after this, what is the structure of XeOF4? XeOF4. First, before going to the structure, how it is prepared? Yes, you have to write this equation. XeF6, partial hydrolysis of the XeF6. Partial hydrolysis. Just we are adding little quantity of water, that is called as partial hydrolysis, not complete hydrolysis. Partial hydrolysis of the XeF6. Two hydrogen atoms combines with the fluorine atoms, two fluorine atoms, that becomes HF, यहाँ से HF बनता, and remaining और Xe, यहाँ पे 6 जाके 4 हो गए और एक एक ऑक्सीजन इधर मिल गया, XeOF4. This is about the preparation of the XeOF4. Partial hydrolysis of the XeF6 gives the XeOF4. Next, once again, what is the structure of this XeOF4? तो xenon 8th ग्रुप का है, 1 2 3 4 5 6 7 8 लाइन्स डाल लीजिए ऐसा. नाउ देन 4 फ्लोरीन एटम्स को ऐड करिए, 1 2 3 4. नाउ नेक्स्ट ऑक्सीजन एटम बोले तो ये 2 इलेक्ट्रॉन्स को ले लेना, एंड देन फिर उसके बाद में ख़त्म हो गया ये. तो एक बॉन्ड पेयर, 2 बॉन्ड पेयर, 3 बॉन्ड पेयर, 4 बॉन्ड पेयर और एक पेयर हो गया. Now then एक lone pair बचा हुआ है. This is the lone pair. In this also xenon undergoes sp3d2 hybridization. In the XeOF4, xenon undergoes sp3d2 hybridization. As a result, how many hybrid orbitals are formed? 3 4 5 6 hybrid orbitals are formed. Whatever it may be. आप देखिए explanation सब details ऐसा लिखने की ज़रूरत नहीं, खाली short में एक sentence लिखना. In the XeOF4, xenon undergoes sp3d2 hybridization, and the shape of the molecule is, what is the shape of that molecule? Square pyramidal shape. कौन से भी दो मिला के 4 मार्क्स में पूछता है, ऐसे क्यों है? तो स्क्वायर पिरामिड शेप. देखिए फर्स्ट 4 फ्लोरीन एटम्स ऐसा जमा लिया मैं, ये हो गया भाई, एक लोन पेयर उतार लिया, ये हो गया, एक डबल बॉन्ड हुआ था ऑक्सीजन से. दिस इज द शेप इज कॉल्ड एज स्क्वायर पिरामिडल शेप. दिस इज अबाउट द XeOF4 स्क्वायर पिरामिडल शेप विथ वन लोन पेयर. XeOF4 के बारे में समझा नो. नेक्स्ट अबाउट द xenon trioxide and xenon tetroxide. Xenon trioxide and tetroxide. Xenon XeO3 trioxide, xenon tetroxide XeO4. So the configuration 5s2, 5p6 is the configuration. 5s2 is this one, 5p6 is this one, 1 2 4 5 6. There is no electron in the d orbital. See here, for the formation of XeO3, it undergoes third excited state. एक इलेक्ट्रॉन इधर डाल दिया, ये सेकेंड वन, ये थर्ड एक्साइटेड स्टेट में लेके गया. Third excited state configuration is 5s2, 5p3. We are removing 3 electron. We are transferring this 3 electron into the d orbital, 5d orbitals. Now then, this is the 5d3 configuration. So 5s2 like that only. Now next 5p3, 1 2 3, 5d3. This one 5d3, 1 2 3. Now then it undergoes. You have to remember this. In this, xenon undergoes sp3 hybridization. sp3 hybridization, as a result of that, 4 hybrid orbitals are formed on the xenon Xe. Now then one lone pair is present. Remaining 3 overlaps with the oxygen atoms and forms 3 sigma bonds. Always hybridized orbital forms sigma bonds, and unhybridized orbitals, these are the d orbitals. Each one forms pi bonds with the oxygen atoms like this. So this is the structure of the molecule, pyramidal shape. This is about the structure of XeO3. XeO3 is having pyramidal shape. Then XeO4. In this, Xg undergoes sp3 hybridization. Once again, a hybridization of the xenon is sp3 only. Both in the case of XeO3 and XeO4, hybridization of the xenon is sp3 only. But here in this fourth excited state, I am repeating that configuration 5s2, 5p6, 5d0. This is the ground state configuration. And see here, this is the 1 2 3 4 5 6 ground state configuration. No electron in the d orbital in the ground state. First excited state, this is the second excited state, this is the third excited state, and this is the fourth excited state. चारों इलेक्ट्रॉन को एक्साइट कर लेना है. फोर्थ एक्साइटेड स्टेट में चलेगा 5s1, 5p3 एंड 5d4 कॉन्फ़िगरेशन. 5s1 this one, 5p3 1 2 3 and 5d4 configuration 1 2 3 4. In this also xenon undergoes sp3 hybridization. As a result of this hybridization on the xenon, 4 hybrid orbitals are formed. Each one overlaps with the oxygen atoms and forms the 4 sigma bonds. As a result of this, XeO4 sigma bonds are formed. Now then this remaining 4 unhybridized orbitals forms pi bonds with the oxygens like this. The shape of the molecule is the tetrahedral shape. This is the shape called as the tetrahedral shape. This is about the xenon compounds. Xenon forms the two types of oxides, XeO3 and XeO4. XeO3 is having trigonal shape in which xenon is present in sp3 hybridization. XeO4 is having tetrahedral shape in which middle element xenon undergoes sp3 hybridization only. So these are the structures of the XeO3 and XeO4. Now what are the uses of helium? ये थोड़ा modern C diverse uses a mixture of He and oxygen. He plus oxygen mixture is used. Mixture is used for what? For artificial respiration. Artificial respiration. C diverse used a mixture of He plus O2 for artificial respiration. For the respiration purpose, a mixture of He plus O2 is used because He is very less soluble in the blood. The solubility of the helium is very less in the blood, therefore only oxygen is soluble. So unnecessary inert भी है और less soluble है, इसीलिए He plus oxygen के मिक्सचर को लेके गए तो ऑक्सीजन जल्दी से soluble हो जाता. So ये एक VSAQ है, चैप्टर का important VSAQ एंड रिमेनिंग स्ट्रक्चर्स ही पूछता. So what is this VSAQ? Modern diving apparatus uses a mixture of He plus O2 for the respiration. Why it is used means because helium is very less soluble in the blood. Solubility of the helium is very less, that's why a mixture of He plus O2 is used for respiration purpose. Whom use that a mixture of He plus O2, C diverse uses this apparatus in which a mixture of He plus O2 is there. So that is used in the respiration. Now next about the I am explaining you this D and F block elements. D and F block elements वाला chapter समझा रहे. D and F block elements, you know that D block elements are present in between what as P block elements. At here S block elements are there, in the right side P block elements are there, in the bottom of this periodic table F block elements are there. So these are the D block elements which are present in between SP block elements. Those elements in which a last electron is present in d orbital, those are called as D block elements. N-1 D you have to take. Those elements in which last electron is present in N-1 D orbital, those are called as D block elements. These are present in between S and P block elements. These are also called as transition elements except 1B group. Here I am writing this 1B and 2B group elements, except this 2B group elements, which are those zinc and cadmium, mercury. Except these three, remaining all the D block elements are called as the transition elements. All the D block elements means how many groups are there in the D block? There are 10 groups are there, 1b, 2b over. After that 3b resembles with the S block, therefore that 3b is placed beside the S block elements. 3b, after that 4th b, after that 5th b, after that 6th b, after that 7th b, after that in the 8th b 3 columns are present. Okay, 8th B. In the 8th B, how many columns are there? 3 columns are present. Total 10. 7 plus 3, 10 groups are present. And in the D block, 4 series are present. First one is the 3D series, next one is the 4D series, next one is the 5D series, next one is the 6D series. D block elements are present in the 4 series and 10 groups. 1b group, 2b group elements zinc, cadmium, mercury, these are not transition elements, and remaining all these are transition element. 1b, 2b, 1b, 3b, 4b, 5b, 6b, 7th b, 8th b, all these elements except 2b group, zinc, cadmium, mercury. Zinc, cadmium, mercury, these are not transition element because it is having 3d10 completely filled d orbital. It is also having completely filled d orbital, it is also having completely filled orbitals. If the d orbitals are completely filled with this electron, these are not said to be transition. If at least one unpaired electron, see here, instead of writing 10, I am writing the 9 electron. This is said to be incompletely filled d orbital. अगर एक भी इलेक्ट्रॉन कम है, 10 से एक भी कम है, तो उनको क्या बोल के बुला ले सकते हैं? ट्रांसिशन. अगर कंप्लीटली फिलअप होके है तो उनको ट्रांसिशन नहीं बोलते. कंप्लीटली फिलअप होके किस में है? इन विच completely filled orbitals are there. In case of zinc, 3d orbitals contains 10 electrons. In case of the cadmium, 4d orbitals contains 10 electrons. Mercury contains 10 electrons. Okay, so these three are not transition, and remaining all the d block elements are called as transition elements. Now then, due to the due to the following reason, this d block elements exhibit special properties. What is the reason? Because due to the small atomic size and high nuclear charge. This is the one. And second one, unpaired d electrons. Unpaired. This is the most important reason, because due to this, these d block elements exhibits various type of the properties like the colors, catalytic activity, variable oxidation state, like that. Unpaired, due to the presence of unpaired electrons in d orbitals. These d block elements exhibit special properties which are not exhibited by the sp block elements. For example, I am writing these d block elements or transition elements are hard metals with high melting and boiling points. These elements exhibits variable oxidation states. Now next, these elements exhibits the ferro, para, diamagnetism, ferromagnetism. I will explain one by one. These exhibits the magnetic properties. These exhibits the colors. Next, these exhibits the colors. Different ions gives the different colors. Now these are used as the catalyst. These are forms interstitial compounds. These forms complex compounds. These are the special properties exhibited by these d block elements or transition elements. These are hard metals with high melting and boiling point values. These exhibits variable oxidation state, exhibits para ferromagnetism, exhibits colors. These are used as catalyst, forms interstitial compounds, forms complex compounds. Due to these reasons, these exhibit this special type of properties. Okay, I am taking this second property, variable oxidation state. Variable oxidation state means what? General configuration I am writing. D block elements general configuration is ns2 n minus 1d 1 to 10. Okay, for example, I am writing the Mn. Its atomic number is 25. You have to remember the names of the 3D series elements. That is important. Scandium atomic number is 21. titanium atomic number is 22, vanadium 23, chromium 24, manganese atomic number 25, manganese, after manganese iron 26, now then cobalt 27, nickel 28, copper Cu 29, and this is the zinc is the 30. Okay, you have to remember this atomic numbers of the 3D series elements and names also: canadium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Manganese atomic number is 25. I am writing the last configuration. Last configuration is 4s2 3d5 is the configuration. So this is the last shell and this is the n minus 1 d shell. What is the variable oxidation state? This manganese, by losing the 2 electron from last shell, that gives the +2 oxidation state. For example, in the MnCl2, manganese loses its electron from the 4s orbital. How many electrons are there? 2 electrons are there. By losing this 2 electron, manganese exhibits +2 oxidation state in the MnCl2. And it also loses the electron from the n-1d orbital. That means d block element loses the electron from ns and also from the n-1d orbitals. They loses the electron from last shell and also from the n-1d shell because energy difference between these two shells. इन दोनों के बीच में एनर्जी डिफरेंस कम रहने से इलेक्ट्रॉन ns से पहले जाते उसके बाद में n-1d से जाते. They loses the electron from the ns orbital and also from the n-1d orbitals. If they loses the electron from the ns orbital, that gives one oxidation type, one type of the oxidation state. If they loses the electron from the ns and also from the n-1d, for example, I am taking this manganese in the MnCl2, manganese loses 2 electrons from the ns orbital, that's why its oxidation state is +2. In the KMnO4, it loses how many electrons? It loses the ns electron and also n-1d electron. In the KMnO4, oxidation state of the manganese is +7. So what is the reason why these elements gives the different oxidation state, different stable oxidation state? Means they loses the electron from the last shell first. Now then they also loses the electron from the n-1d orbitals. Minimum oxidation state is equal to the ns electrons. Last shell में कितने electrons है? वो 2 हो सकते, 1 हो सकता. That is its minimum oxidation state. And maximum oxidation state is sum of the what? ns and n-1d orbital. इन दोनों में कितने electron है उतने ऐड कर लेना, वो maximum oxidation state होता. 3D सीरीज में मैक्सिमम कौन बता रहा? मैंगनीज +7 बताता. 4D सीरीज में रुथेनियम +8 ऑक्सीडेशन स्टेट. 5D सीरीज में ऑस्मियम exhibits the +8 oxidation state in the compound osmium tetroxide. So in the periodic table, most oxidation state element is the osmium. Osmium exhibits +8 oxidation state. So all this introduction जो भी बोला मैं समझने के लिए बोला मैं आपको. अभी जो क्वेश्चन है ना, ये क्वेश्चन एक VSAQ इंपॉर्टेंट है. यहाँ से व्हाट इज द VSAQ? अब VSAQ क्या है भाई? वो सी हियर, विच वन इज स्टेबल अमॉन्ग द Mn+2 और Fe+2. ये दो दे दिया भाई, ये Mn+2 दिया, Fe+2 दे दिया. तो Mn+2 का कॉन्फ़िगरेशन पहले लिख ले रहा हूं मैं. एटॉमिक नंबर 25 था, इसका कॉन्फ़िगरेशन क्या आया था? 4s2 3d5 था. और इसका आयरन का जो नंबर है 26 है. कॉन्फ़िगरेशन क्या था? 4s2 3d6 कॉन्फ़िगरेशन है. चलिए +2 मतलब 2 इलेक्ट्रॉन्स निकाल देना. 4s0 पहले इससे इलेक्ट्रॉन्स निकालना s ऑर्बिटल से. 4s0 3d5. नो देन यहाँ पे Fe+2 मतलब 4s0 3d6. ये d ऑर्बिटल उतार ले रहा हूँ मैं. d ऑर्बिटल हाउ मेनी इलेक्ट्रॉन्स आर देयर? 1 2 3 4 5 electrons are there. In case of this, how many electrons are there in the d orbital? 1 2 3 4 5. Only 5 are there. So 1 2 3 4 5 and another one is this one is the sixth one. That means in case of the Mn plus 2, half filled configuration is present, half filled d orbital is present. And in case of the Fe plus 2, half filled configuration is not present. Okay, if elements or ions which are having half filled configuration, half filled d orbitals are stable. That means that here Mn plus 2 is stable than the Fe plus 2. In Fe plus 2, half filled configuration is not present, while in Mn plus 2, half filled d orbital configuration is present. This is about the VSAQ. Among the Mn plus 2, Fe plus 2, which one is the stable? Mn plus 2 is stable. Now next about the exhibiting the para and ferromagnetism or diamagnetism. What is the magnetism? See here, condition to exhibit the magnetism. That means when the substance is suspended और एक ट्रांजिशन एलिमेंट को मैं एक्सटर्नल मैग्नेटिक फील्ड हेज गॉस में रख दिया, तो इनसे जो मैग्नेटिक फोर्स ऑफ लाइंस आ रहे हैं, इनसे जो मैग्नेटिक फोर्स ऑफ लाइंस आ रहे हैं, इसके अंदर से ऐसा जाते, कब जाते? लोन पेयर इलेक्ट्रॉन, अनपेड इलेक्ट्रॉन अगर रहा तो क्या होता? एक्सटर्नल मैग्नेटिक फील्ड के जो मैग्नेटिक फोर्स ऑफ लाइंस इजी से ट्रैवल होते. Due to the presence of the unpaired electrons, magnetic force of lines are easily traveled towards through this substance. As a result of this, they are attracted towards the magnetic field. Those substances are called as the paramagnetic substances. Paramagnetic substances. Para means which are attracted towards the magnetic field. The condition for the paramagnetism is that must contain at least one unpaired d इलेक्ट्रॉन. d ऑर्बिटल में एक सिंगल अनपेड इलेक्ट्रॉन रहना चाहिए. ओके, अगर पेड इलेक्ट्रॉन्स ऐसा है, पेड इलेक्ट्रॉन्स है, पेड इलेक्ट्रॉन्स है, तो वो कौन सा मैग्नेटिज्म एग्जिबिट करता? डायमैग्नेटिज्म एग्जिबिट करता. व्हाट इज द डायमैग्नेटिज्म? When element is suspended or placed in external magnetic field, see here, due to the presence of the paired electrons or vacant d orbital, this magnetic force of lines are not easily travels from this substance. Due to that, this substance is repelled by this magnetic field. Magnetic field से repel होता. So ऐसे प्रॉपर्टी को मैग्नेटिक फील्ड से रिपेल्ड हुआ तो थोड़ा एक्सिस इधर उधर बदल जाता या हट जाता. इसको क्या बोलते? बोले तो डायमैग्नेटिक सब्सटेंस बोल के बुलाते. Which is repelled by the magnetic field is called as diamagnetism. Substances which are attracted towards the magnetic field are called as paramagnetic, and this property is called as paramagnetism. The condition is at least element or ion contains the one unpaired electron. एक unpaired electron रहा तो वो paramagnetism exhibit करता. अनपेड इलेक्ट्रॉन नहीं है, पेड इलेक्ट्रॉन्स रहे तो वो डायमैग्नेटिज्म एक्सप्लेन करता. ठीक है भाई, चलो मैं एक एग्जांपल लेके समझा रहा हूँ मैं. सी हियर Zn+2 है. इन द जिंक सल्फेट Zn इज प्रेजेंट विद +2 ऑक्सीडेशन स्टेट, and copper sulfate CuSO4, in this also copper is present in the +2 oxidation state. See here Zn+2 configuration I am writing. Atomic number of the Zn is 30. Configuration is 4s2 3d10 configuration. Zn+2 means 4s0 3d10 configuration. D10 configuration समझ रहे होंगे आप लोग. D10 configuration 1 2 3 4 5 6 7 8 9 10 totally filled d orbitals are there. Therefore a zinc +2 ion Zn+4 is not attracted towards the magnetic field, it is repelled by the magnetic field. So Zn+2 is diamagnetic. And while the copper sulfate is the paramagnetic, because see that in the copper one unpaired electron is there. What is the configuration of the copper? This is the configuration. 4s1 3d10 is the configuration, plus d10 configuration लिख ले रहा हूँ मैं. पहले d10 configuration 4s2 3d10 1 2 3 4 5 6 7 8 9 10. चलो Cu+2 है यहाँ पे. +2 बोले तो क्या लिखना? 4s0 3d9 configuration लिख लेना. 3d9 configuration, it is having 3d9 configuration 1 2 3 4 5 6 7 8 and 9. It has one unpaired electron. one unpaired electron. That's why it is attracted towards the magnetic field. Copper sulfate is the paramagnetic one, while zinc sulfate is diamagnetic one. To calculate the magnetic momentum, we are using this formula, under root n into n plus 2 Bohr magnetons, BMs. This is the formula is used to calculate the magnetic momentum. So what is n here? N is the number of unpaired electrons. Unpaired electrons. For example, in case of this, there is no unpaired electron. 0 is there. In case of the copper, how many unpaired electrons are there? All these are paired. One unpaired electron is there. That's why you have to substitute this unpaired electrons at here. One unpaired electron is there. 1 into 1 plus 2 Bohr magnetons. These are the units. So then what you will get? 3 into 1, you will get the 3 only. Under root 3 means what? 1.7. This is the magnetic momentum in case of the Cu प्लस 2 आयन. कॉपर सल्फेट में Cu प्लस 2 रहता और इसका मैग्नेटिक मोमेंटम कितना है? 1.3 BMs है. Now next, what is the magnetic momentum in the Fe plus 2, Fe plus 3, Mn plus 2? लास्ट एग्जाम में पूछा हो. Fe plus 2 ले लिया, Mn plus 2 ले लिया. चलो Fe plus 3 में भी सेम वही नंबर्स के इलेक्ट्रॉन्स रहते. देखिए आप, Fe plus 2, 26 atomic number, configuration 4s2, 3d6 configuration है भाई आयरन का. 4s2 is this one, d6 configuration is this one, 1 2 3 4 5 and 6. See here, Fe plus 2 means you have to remove the 2 electron. The configuration is 4s0, 3d6 configuration. 4s0 को वैसे ही रख दो. d6 configuration 1 2 3 4 and this is the sixth electron. How many unpaired electrons है? ये जोड़ी हो गई है. paired electron है. unpaired कितने? 1 2 3 4. 4 paired unpaired electrons है. 4 unpaired electrons है. तो फॉर्मूला में सब्स्टिट्यूट करो. अंडर रूट how many are there? 4 unpaired electrons, n into n plus 2. so this is the formula. so कितने हो गए भाई? ये यहाँ पे कितने हो जाते हैं? 6 into 4 अंडर रूट 24 आ जाता है. ओके, तो ये 24 आ गया. रूट 24 बोले तो 5 5 25 ना, तो इसका जो रूट वैल्यू आती वो 4.8 और 4.9 रहता. ओके, तो रूट 25 की वैल्यू कितनी आएंगी भाई? 5 आएंगी. 24 रहने से यहाँ 4.8 और 4.9 लिख सकते हैं. अब दिस इज अबाउट द मैग्नेटिक मोमेंटम ऑफ द Fe plus 2. Mn plus 2 का मैग्नेटिक मोमेंटम कैलकुलेट करना है. Mn का नंबर कितना है? 25. 25 का कॉन्फ़िगरेशन क्या है? 4s2 3d5 is the configuration. 4s2 3d5. D contains how many electrons? 5 electrons. Mn plus 2, ये दो को निकाल दो. d5 कॉन्फ़िगरेशन बचा. How many unpaired electrons are there? 5 are there. Therefore n की जगह क्या सब्स्टिट्यूट करना है? 5 को सब्स्टिट्यूट करना है. ओके, 7 अंडर रूट क्या आएगा यहाँ पे? 35. 6 6 36 होता, तो यहाँ पे क्या आएगा आपको? 5.8 is the magnetic momentum of the Mn plus 2. so same like that only Fe plus 3 में कितना कॉन्फ़िगरेशन आता है? इतना ही आता है. ये 5 अनपेड इलेक्ट्रॉन्स आते, तो सेम 5.8 ही मैग्नेटिक मोमेंटम रहता है Fe plus 3 में. so this is about the magnetic momentum of the transition or d block elements. I was completed 2 properties. first one is the variable oxidation state. variable oxidation state से एक simple question है, Mn plus 2 Fe plus 2 में से कौन सा स्टेबल है? ओके, तो आप क्या लिखना? Mn plus 2 is stable because due to half filled configuration. नेक्स्ट सेकेंड वन, सेकेंड जो प्रॉपर्टी में पढ़ाया, पैरा डायामैग्नेटिज्म के बारे में पढ़ाया मैं. The substances which are attracted towards the magnets, those are called as the paramagnetic substances, and that is called as paramagnetism. The condition is for the paramagnetism is that must contains one unpaired electrons. एक अनपेड इलेक्ट्रॉन है तो वो मैग्नेट के तरफ अट्रैक्ट होता, अनपेड इलेक्ट्रॉन नहीं है तो मैग्नेट के तरफ अट्रैक्ट नहीं होता. Okay, why copper sulfate is diamagnetic and zinc sulfate is paramagnetic? Reason is that is only, what is the reason? Zinc, in the zinc sulfate Zn is present in +2 oxidation state, all are paired electrons are present, while in the copper sulfate copper is present in a +2 oxidation state, one unpaired electron is there. That's why copper is attracted towards the magnetic field, that is paramagnetic. And to calculate the magnetic momentum, we are using the formula under root n into n plus 2. So in a previous exam, that question is asked, calculate the magnetic momentum of Fe plus 2 Mn plus 2. Just I was explained that answer. Now then after that, third property, what is that property? Colors. These exhibits the colors. D block elements exhibit the colors because the condition to exhibit the colors is unpaired electron. At least one unpaired electron रहना है आपको d orbital में. At least one. This is called as paired. No, unpaired बोले तो at least one. कहीं भी भाई at least one. एक तो भी रहना, कम से कम एक तो भी रहना to exhibit the colors. पूरे pairs है तो color exhibit नहीं हो करते. चलो, now then why this exhibits the colors? Why this exhibits the colors means they absorb the sunlight, they absorb the one color from the sunlight and liberates the complementary colors. When they are absorbs the color, that means energy, their electron is get excited, electron excite होता, फिर de excite होता. Due to that phenomena क्या हो रहा बोले तो colors exhibit कर रहे हैं. तो यहाँ पे देखिए आप, एक dt transition phenomena है. This exhibits colors because due to what? dt transition. What is the dt transition? See here, I am writing the 5d orbitals, total 5d orbitals लिख रहा हूँ मैं. First one dxy, dyz, dzx, dx square minus y square, dz square. See that dxy means this is the x and this is y. Lobes are present in between the axis. In also dyz, yz बोले तो y यहाँ लिखना, z यहाँ लिखना. Same structure. Lobes are present in between the axis. dzx बोले तो z इधर लिखना, x लिखना. Same structure है. Lobes are present in between the axis. In case of the dx square minus y square, this is x and y, dx square and y square. Lobes are present on the axis, and in case of the dz square, lobes are also present on the axis. So when the sunlight is fall, if they are having unpaired electrons, what is going on? See here. So energy of this degeneracy of this 5 orbitals is lifted. Degeneracy means before forming the complex or forming the ions, all these d orbitals are having same energy. Same energetic orbitals are called as degenerate orbitals. Now then this degeneracy is lifted while they are forming the compounds. 3 orbitals are having less energy and 2 orbitals whose lobes are on the axis are having high energy. Okay, so if they are having unpaired electron, this lower energetic d electron is transferred into the higher energetic d orbital. This is called as dd transition. dd transition. Okay, due to this dd transition, whatever it may be, due to the excitation of the color, they exhibit, due to the excitation of the electron, they exhibit the colors. मैं खाली फिनोमिना समझा, एग्जाम में ये नहीं पूछता, खाली ये एक याद रखिए आप, ड्यू टू दी dt ट्रांजिशन दे एग्जिबिट्स दी कलर्स. अगर एक अनपेड इलेक्ट्रॉन रहे तो एक कलर देते, 2 अनपेड इलेक्ट्रॉन रहे तो और एक कलर आता. Colors are depends upon the number of unpaired electron, that means depends upon the oxidation state also. Element with different oxidation state gives the different colors. Example Fe plus 2, इसके अंदर कितने अनपेड इलेक्ट्रॉन है भाई? 4 अनपेड इलेक्ट्रॉन है, दैट गिव्स द ग्रीन कलर. Fe plus 3 ले लो भाई, ये कौन सा कलर देता? रेड कलर देता, ड्यू टू द प्रेजेंस ऑफ हाउ मेनी अनपेड इलेक्ट्रॉन्स? 5 अनपेड इलेक्ट्रॉन्स. तो अनपेड इलेक्ट्रॉन्स के नंबर्स बदल गए तो कलर्स भी बदल जाते. सो अब ये हो गया, ये एक्सप्लेनेशन हो गया. तो देन फिर से एक क्वेश्चन दे रहा हूं मैं आपको. Zn SO4 इज कलरलेस. and copper sulfate is colorful. What is the reason? कॉपर सल्फेट में फिर से आप वही रीजन बनाना, एक अनपेड इलेक्ट्रॉन है. इन केस ऑफ द कॉपर सल्फेट, इन द कॉपर, in the d orbital, one unpaired electron is present, while in the zinc sulfate, in the zinc d orbital, there is no unpaired electron is present, all are paired electrons are present. Therefore zinc sulfate is colorless, zinc salts are colorless and copper salts are colorful. So this is about the colors. Now next, aqueous CuSO4 is colorful and anhydrous CuSO4 is colorless. What is the reason बोले तो aqueous CuSO4 में water d orbital को split करता, crystal field splitting of the d orbitals gives the colors to the aqueous CuSO4. Okay, this is about the colors of the ट्रांजिशन एलिमेंट्स. नो इसके अंदर जो भी पढ़ाया मैं VSAQC है, वो जो जब से पढ़ा रहा हूँ मैं ये, तो टेक्स्ट बुक देख लीजिए. अब VSAQs में कलर्स में why ZnSO4 is colorless, why CuSO4 is colorful बोले तो you have to give the answer that is in the CuSO4 copper has one unpaired electron, that's why it is colorful. Now after that after the colors, these are used as the catalyst. Catalyst कैसा use करते हैं इनको? Catalyst in the hydrogenation of the aisles. Okay, aisles का hydrogenation means unsaturated compounds are treated with the hydrogen in the presence of the catalyst nickel. Nickel is used as the catalyst. Okay, in the unsaturation, the saturation of the aisles, that means unsaturated hydrocarbons are converted to the saturated hydrocarbons by the addition of H2 in the presence of the nickel catalyst. That is the preparation of vanaspati. In that, nickel is used as the catalyst. Here transition elements are used as the catalyst. You know that in the preparation of sulfur trioxide, that is in the manufacture of H2SO4, V2O5 vanadium pentoxide catalyst is used. Now then you know that in the preparation of the NH3 ammonia, we are using which catalyst? Iron catalyst is used. Next, in the preparation of HNO3 by the Ostwald method, which is the catalyst is used? Platinum. All these are the transition elements. Transition or D block elements are used as the catalyst because these exhibits the variable oxidation state. Due to this property, they are acts as the catalyst. They binds with the one oxidation state with the reacting mixture. रिएक्टिंग मिक्सचर को एक ऑक्सीडेशन स्टेट से कंबाइंड हो जाते हैं, इनके सरफेस पे बिठा लेते हैं, फिर ऑक्सीडेशन स्टेट बदलते ही प्रोडक्ट्स इनके सरफेस से निकल जाते. ड्यू टू दिस वेरिएबल ऑक्सीडेशन स्टेट, these are exhibits colors. This is about the catalytic action of the D block elements. Okay, I think this much is enough regarding to the general properties of the D block elements. Next I will explain you about the coordination compounds. कोऑर्डिनेशन कंपाउंड्स के बारे में समझा रहा हूं मैं. What are the coordination compounds? Just you see that I am adding the two or more compounds, KCl and MgCl2, 6H2O. These three are the stable one. ये तीनों भी stable है. Stable compound को mix करके एक बड़ा compound form कर रहा हूँ, उसको क्या बोलते हैं? Additional compound बोलते हैं. Additional compound. By joining three or more stable compounds, we will get the two or more stable compound. We will get the big compound. That those compounds are called as additional compounds. Additional compounds are of two types. First type is called as the double salts, and second type is called as complex compounds. Complex compounds. What are the double salts? These are the additional compounds only, but these loses the identity when these are dissolved in water. KCl MgCl2 6H2O इसके अंदर पानी में डाल दिया तो KCl जाके K प्लस हुआ, Cl माइनस हुआ, MgCl2 जाके Mg प्लस 2 होता, Cl माइनस बन जाता हो, तो they loses their identity. अब पहले के जैसे नहीं है, वो आयनिक फॉर्म में चले जाते. If they loses the identity, such type of the double additional compounds are called as double salts. Additional compounds which does not loses their identity in the water, water में डाले तो for example देखिए K4Fe CN taken 6 times, FeCN6 को और KCN को मिला के मैं क्या करा, ये कंपाउंड प्रिपेयर करा, दैट इज कॉल्ड एज K4FeCN6। पर डिसॉल्विंग इन वाटर इसके प्रॉपर्टीज रिटेन होते, इसकी आइडेंटिटी लूज नहीं होती, which does not loses their identity. Such type of the additional compounds are called as which compounds? Complex compounds। complex compounds को coordinate compounds बोल के भी बुलाते हैं, because in the complex compound coordinate covalent bond is present। ठीक है भाई, ये कॉम्प्लेक्स कंपाउंड्स के बारे में पढ़ते ही पहले देखिए बड़े ब्रैकेट्स याद आना। एडिशनल कंपाउंड्स है, बड़े कंपाउंड्स है, इसमें ये जो बड़ा स्फीयर है इसके अंदर कौन से भी एलिमेंट्स मैं लिख रहा हूं, तो ये सबको मिला के क्या बोलते हैं मालूम है? कोऑर्डिनेशन। कोऑर्डिनेशन, कोऑर्डिनेशन स्फीयर बोलते, यानी किसके बीच में समझौता हुआ भैया? मेटल और लिगेंड्स के बीच में समझौता होता, उसको बोलते कोऑर्डिनेशन। ओके, K4FeCN6 ले रहा हूं मैं, Fe है ये, Fe यहाँ पे देखिए CN टेकन 6 टाइम्स। तो यहाँ पे जो भी लिख रहा हूँ मैं, ये ब्रैकेट में जो लिख रहा हूँ, द थिंग्स विच आर रिटन और टेकन इन दिस ब्रैकेट, दैट इज कॉल्ड एज कोऑर्डिनेशन स्फीयर। कोऑर्डिनेशन स्फीयर में तो जनरली इसमें एक मेटल रहता, उसको क्या बोल के बुलाते हैं? सेंट्रल मेटल बोल के बुलाते हैं, सेंट्रल मेटल। नाउ देन सेंट्रल मेटल के साथ में कोऑर्डिनेट कोवेलेंट बॉन्ड से जो लगा हुआ रहता, इसका कोऑर्डिनेशन स्फीयर है, इसीलिए इन दोनों के बीच में कोऑर्डिनेट कोवेलेंट बॉन्ड रहता। तो केमिकल विच आर बाइंडेड विद द मेटल विद द कोऑर्डिनेट कोवेलेंट बॉन्ड, दिस टाइप ऑफ द केमिकल्स, दिस आर द केमिकल स्पीशीज आर कॉल्ड एज क्या बोल के बुलाते? लिगेंड्स बोल के बुलाते। ओके, तो यहाँ पे थोड़ा टर्मिनोलॉजी देख लीजिए। The things which are written in this big bracket, that those things are called as, that is called as coordination sphere. Now metal element which is present in the coordination sphere is called as central metal, and the chemical substances which are binded with the metal with coordinate covalent bond are known as ligands. Next, how many ligands are there? You have to see, that is called as coordination, coordination number, coordination number with the metal. How many ligands are there? That is called as the coordination number. Now then after that, how these ligands are arranged around this iron metal or whatever it may be, सेंट्रल मेटल के तरफ ये लिगेंड्स कैसा अरेंज होके है, ये लिखने को क्या बोलते हैं? कोऑर्डिनेशन पॉलीहाइड्रॉन बोल के बुलाते हैं, कोऑर्डिनेशन पॉलीहाइड्रॉन। दिस इज द टर्मिनोलॉजी विच इज यूज्ड फॉर द कॉम्प्लेक्स कंपाउंड्स। कॉम्प्लेक्स कंपाउंड्स में ये टर्म्स यूज करते हैं। सेंट्रल मेटल बोले तो स्फीयर में है सब मेटल, इसके साथ में लगा हुआ है तो लिगेंड बोलते हैं। नाउ देन how many are there, how many ligands are there, that is called as coordination number. Now next, polyhedron, arrangement of this ligand around this iron is called as coordination polyhedron. So this is about the introduction of coordination compounds, and remaining thing, that is the important SAQ. What is that SAQ? Werner's series of the complexes, and after that IUPAC nomenclature. These two are the important thing left in this chapter. वो हम नेक्स्ट क्लास में समझाते हैं। वर्नर सीरीज और उसके बाद IUPAC नेम्स, उसी से एग्जाम में आता, ये पूरे VSAQs में आ सकते हैं। ये इंट्रोडक्शन पार्ट है, that is important in the VSAQs. Okay, I will continue tomorrow inshallah.